Have you ever walked into a store, asked for a recommendation, and felt like the store associate was just guessing? Or maybe you bought something online, only to get a polite email saying, "Sorry, it's out of stock, we have refunded your money." This is not a story from 10 years ago. It is still happening today. We are living in the age of AI. We can generate realist image, we can write poetry, we can predict the weather, but somehow we still cannot give smart product recommendations or guarantee product availability in real time. The issue is not the people or even the lack of technology. The real blocker is how we manage operational data. Retail systems are messy. Inventory lives in one system, product details in another, customer data yet another. The result is fragmented data and fragmented experiences. When systems do not talk to each other in real time, your AI, your apps, and your store associates are left guessing. To move forward, retailers need to act strategically with their data. You need a platform that brings it all together: inventory, products, customers, and makes that data available instantly across all channels and apps. That is what an operational data layer does, and what a unified commerce strategy is about. And yes, this is exactly where MongoDB fits in. If you want to dive deeper into these concepts, check out the resources linked in the description. So, let's say you are a store associate at Leafy Store, a retail brand with 50 locations. Thanks to the Leafy Associate app powered by MongoDB, you get real-time access to both the product catalog and inventory data, a single view of the operational data. Now imagine a customer asks for a specific product, but your store is out of stock. No problem. Thanks to MongoDB's native geospatial features and real-time unified view of inventory right inside MongoDB, you can instantly check other nearby stores and let the customers know where the product is available. Even better, you can place an order for pickup at the closest location seamlessly for you and the customer. But what if the customer does not ask for a specific product? What if they say, "I'm looking for something rich in probiotics"? Now we are not just dealing with availability. We are talking about intelligent product discovery. Let us break down how MongoDB powers different search strategies behind the scenes. Let us start with Regex, short for regular expression. It is a simple pattern matching method used to find exact phrases or specific text patterns in data. It works well for strict keyword searches, but it has one big limitation. If the data does not contain the exact phrase "rich in probiotics," you get nothing. Regex has been around since the early days of the internet, and while it is a common baseline, it is clearly limited when it comes to smart product discovery. Now, let us talk about MongoDB Atlas Search and how it takes things to the next level. Atlas Search integrates full-text search natively within MongoDB. No external engines, no syncing. Your queries run directly on operational data with less complexity, fewer dependencies, and better performance. If we search for rich in probiotics, Atlas Search returns a range of results: products that contain the word probiotics, others that include phrases like "rich in," and of course, exact phrase matches. What makes this powerful is the flexibility of Atlas Search. You can search across multiple fields, apply boosting, for example, prioritize results where probiotics appears in the subcategory, set up synonyms, and yes, even handle typos. So if the user makes a mistake, they still get relevant results. All of this is driven by Atlas Search indexes, fully customizable to your use case. But remember, this is about matching text structure, not meaning. If you search for green tea, you might still see results like a toner with green tea as an ingredient, because the words appear together, even if what you really meant was just tea. Now we are entering the fascinating world of AI. Two key concepts come into play here: embeddings and vector search. An embedding is how a large language model represents meaning as a vector. Think of it as compressing the essence of text or even multimodal content into numbers. a bit like how DNA encodes biological information. MongoDB can store these vectors embeddings alongside all the metadata of your business data. MongoDB also offers vector search, the ability to find other vectors that are similar to a given input after converting that input into an embedding. If we search for green tea, but this time using vector search, the results will lean more toward tea as a drink than creams with green tea. Here is how the engine works under the hood. The typed query is sent to the Advanced Search microservice, which forwards it to Voyage AI, our LLM embedding provider. The model turns the question into a vector, an embedding that captures its meanings. That vector is then sent to MongoDB, where vector search compares it against product embeddings previously generated using the same model, returning results based on semantic meaning rather than exact matches. But sometimes you don't just want precision from text search or meaning from vector search, you want both. That is where Hybrid Search shines. It combines Atlas Search, text-based, with vector search, semantic into a unified result list. You control the weight of each, so you can tune the balance based on the user intent. If I search a gentle face wash with Zika, semantic search understands I might mean products for sensitive skin, even if the description is worded differently. At the same time, I still want to prioritize the exact ingredients I care about, so I give the text search a smaller boost to make sure those words rank higher. Behind the scenes, Hybrid Search uses Reciprocal Rank Fusion. Atlas Search and Vector Search have different scoring logic, so their raw scores are not directly comparable. Instead, Reciprocal Rank Fusion merges results based on position in each list, so items that rank high in both naturally rise to the top. The result is a smart blend of semantic understanding when it matters and keyword precision when you need it, all in a single query.
A couple of quick updates before we wrap up. While we've been referring to Atlas Search throughout the video, Search is now also available as a public preview in MongoDB Enterprise Server and Community, bringing these advanced capabilities to even more deployments beyond Atlas. And speaking of Search, MongoDB now offers Score Fusion, in addition to Reciprocal Rank Fusion. While RRF merges results based on their position in each list, Score Fusion uses the actual relevance scores returned by each pipeline to calculate the final ranking. This allows you to combine results based on how strongly they match, not just where they appear. You can still assign weights to each pipeline to control the influence of text search, vector search, or others. At the end of the day, you decide how you want to combine your pipelines. MongoDB just gives you the tools to mix and match the way your experience needs.